So this question says a sailboat has some mass and is acted on by a force towards the east. Feel like this is just a two-dimensional four-vector addition question. So let me just do it that way rather than using standard strategy. Let me just add the vectors and then just go that way. So and I think the way the axes are defined is east is my kind of like my x-axis, and north is like my y-axis plus y. So I'll draw my forces that way. So there's a force of 1 times 10 to the 3 Newton towards the east. So there's F1. And then there's a wind x behind the sail with some force of some magnitude, F2, in a direction that's 40 degrees north of east. Let me just do head to tail addition and draw it this way. Here's 40 degrees. And I think I have done this kind of question before. The last time I used the law of cosine to just to figure out the magnitude of the force here. Let me not do it this way for really two reasons. One being, I did use the law of cosine last time, so for variety, let's just switch it up. And the second reason, the other question that I did it that way, it wasn't asking me for angles. Here, since now I need to figure out angles, I need the component values anyway. So let me just add the forces by component. So to add the forces by component, I'll need to break F2 into the eastern component, F2E, and the northern component, F2N, and I can use so and ka to break this down. The northern component is the opposite side, so this should be the F2 times the sine of 40 degrees, and the eastern component is the adjacent side, so this should be F2 times cosine of the 40 degrees. So the eastern component of the net force should be F1 plus F2 cosine 40 degrees. I'll get some number. So let me call this net force in the eastern direction. And the northern component is just from the first two, F2 times the sine of 40 degrees. Let me call that net force in the northern direction. And I'm not writing down numbers because I can keep all those numbers just in Wolfram alpha and never have to copy numbers with the significant figures and not deal with the potential rounding errors. So I'll have this number, I'll have this number. Once I do, then the answers that they are looking for, the angle and the acceleration, I can get it this way. So for the angle, I use TOA portion of this. Mainly, I guess here there's no real big difference either way. Still, these x and the y components, they are earlier in calculation. If I'm trying to use a so or ka, I'll have to use the hypotenuse, which is the next step in calculation. What if I made a mistake? Using steps, numbers that involve fewest steps, make sure that if I make a mistake somewhere, that mistakes affects as few things as possible. So I'm going to use this relationship. The tangent of the angle theta is given by the opposite over adjacent. So the opposite, northern, net force in the north direction divided by net force in the eastern direction. And I have a good sense it's going to be an acute angle. So let me just make this into theta is the arctangent of the northern component divided by the eastern component. Let me get the number and plug it in. Arctan of the net force in the x direction, that's gonna be F1 1E3, and let me just keep everything in basic SI units and I won't have to plug in units. So 1E3 plus, I should have a parenthesis around the whole thing to kind of wrap them. The F2, 4 times 10 to the 3 Newton, basic SI unit, times the cosine of 40 degrees. That's the eastern component. So I'm going to be dividing by it. Let me do the northern component. I got distracted. So that's the 4E3 times sine of 40 degrees. So the northern component divided by the eastern component, that should be the tangent theta. So doing arctangent is this. Now this is the number in the radians. I have a sense if I press enter, it'll give me an angle in degrees. So let me use that. Yeah, there's an answer in degrees. So 32.32. Guess that's probably right. It's less than 40 degrees. And yeah, this is a larger force. So I think that makes sense. 32.32. Okay, so I want you to do the angle first, both because it's more directly accessible from force, and also because you know acceleration is in the same direction as net force, and because I from a report from one of your classmates, I happen to note this first part is bugged. There's an error in the answer key. So let me give you the correct answer first. I will tell you that it will be graded as incorrect, but that's the answer key being wrong, not me being wrong. So the net force, the magnitude of the net force, is given through the Pythagorean theorem. You know, I have the x and the y component, so the magnitude should be square root of the x component squared plus the y component squared. That's the net force. Oh, but it's not asking for the net force. It's asking for the acceleration. So I need to divide this entire thing by the mass which I'm given. So I'll do that. So let me do the calculation in Wolfram alpha. So this was the x component. So I'm gonna take this and square it, add that to this y component or the northern component that I'm also going to square. Don't need arctangent anymore, but I do need a square root. So square root of the entire thing. That's the net force divided by the mass, 1.5 times the 10 to the 3. I think all these 10 to the 3s will cancel out. 1.5 E3 kilogram. But let me put it in for now. So, oh yeah, here I can actually just copy and paste this in. So again, if you put in the whole thing, looks unprofessional, round it to 3.21. Now I will tell you this will be graded as incorrect. And it's not because there's any mistake on my part. This is the correct answer. I looked at the code while trying to address a question from your classmate, and the error in the solution is it's dividing by square root of the mass. Like, why? That's so here. Ooh, that looks really large, but that's interesting. I think in the answer key they also neglected these powers of 10, which you know when you do it properly they cancel out. So simply neglecting these powers of 10 is fine. But I think if the question author hadn't ignored those like from the beginning, he might have been able to spot his coding error, because that this large number tells you, oh yeah, something's wrong. But 3.93, so it'll grade that as correct. But again, that's a wrong answer because you're dividing by square root of the mass, some version of it. Really, the correct answer, even though it's grading it as incorrect, the correct answer is this. Not that. The one without the square root. The correct answer is this. 3.20. And I already reported the 3.21. This is the correct answer up to 3 significant figures. And I already reported this to the question author, and hopefully he'll fix it. So, but I thought since this is a relatively minor mistake, I can still do the question, and we'll get the question fixed soon. So next semester, students, do it correctly, and it'll be graded as correct.